Hey guys, welcome to my YouTube channel once again. And guys, it's been a very long time that or about I have not recorded or captured any video. I was suffering with some personal problems, so I couldn't record any video. Almost it's been like 4 to 5 months. I couldn't record any video. So now today I'm going with the same topic, and I will continue further. Okay, so in this video today we are going to learn about one sec, let me take highlighter. Okay, so today we are going to learn about what is flow control. Okay, first of all, what is flow control we will understand, and there are a couple of techniques, or you can say methods, or you can say like ways to control flow control. Okay, so I hope this is going to be very useful video for you guys, and you will have something valuable from this video, because I know you will spend some time. Definitely you should get some sort of amount from here, or value, I should say value, if you are spending time and giving your time. So guys, let me begin with the very first one. Is what is flow control, first of all. Okay, because first of all we should understand what is topic and what we are going to learn, then only we can make it possible to catch something from there. Okay, then I will tell you about buffering and couple of things here. So first of all, let me tell you the definition of flow control. What is flow control here? So guys, as I told you, it is a technique, first of all, I should say. So you can see, like, flow control is a class of technique for optimizing the exchange of data between systems. So very simple. You have two systems here, one is here and the second one is here. So you want to have a exchange of data. Okay, so how quickly it is happening, how beautifully it is happening, how successful it is happening, it happens only because of flow control, or it is totally depend on flow control how it is happening. Okay, and optimizing is like something like, very simple thing, how good it is happening, how successful that transmission or exchange is happening. So it is a technique of, or you can say it is a technique of, or technique for optimizing the exchange of data between two systems. I hope it is very clear. So there should be optimization, okay, for data exchange between two systems. So we can use this flow control technique. Okay, and for example, if too much data is sent at once, for example, you have one computer here. Once again, let me tell you, sender, and this is receiving. Okay, this machine. So for example, too much data is going from this side. Too much data is going from this sending to receiving, okay, at once. The receiving node can become overwhelmed, dropping packets that arrive too quickly to process. Yes, very simple. This PC or this computer or this desktop or this node is not capable to handle how quickly this data is coming from this side. Okay, so in this condition, what will happen? It may drop certain data, certain packets. Okay, this is a scenario, and it is possible, it can happen. Okay, so in this condition, flow controls play its role. Now let's see, as I told you, if too much data is going, so what will happen? Maybe this receiving device may not handle that much data, or it may drop certain data. Okay, now what will happen? We'll see in other scenario. For example, if too little data is sent, so here you saw like too much data was going, now too less or too little data is going. The receiver sits idle, waiting for more data to arrive. So now if less data is going, very less data is going from here. So for example, 1 2 3 data has to go, but only one data is going this side. So this PC will wait until 2 3 arrives here. Okay, in case of little data is sent. And if too much data is sent, it may drop 2 or it may drop 3 if this data is going too quickly. Now buffering and data window are two flow control techniques commonly used in computer networking. So we are talking about network computing, or computer networking. So here, to control this flow control, this quick data delivery or transmission, or too little data transmission. To control this, there are two techniques. One is buffering and second one is data windows. So these are the two flow control techniques commonly we use in this computer networking. So I will tell you about both one by one. What is buffering, what is window, this data window. Okay, and next slide. So guys, I hope this scenario is very simple. Flow control, what is the definition of flow control? So it is nothing but it is a technique for optimization or optimizing the exchange of data between two systems, because there is a possibility or there are possibilities one PC may send very quickly the data and the receiving device may not be able to handle that quick data exchange, or there's a possibility from sender device to send very little or very less data. In that condition, that receiving device will wait until more data to arrive. So this is a situation. So here how buffering play a role and how data window play a role, we will understand, we will learn in next slide. Okay, so guys, here now I will show you example of buffering. So guys, again I will tell you, buffering is a flow control technique. Just now I told you there are two techniques. Okay, there are two techniques of flow control. One is buffering and second one is data windows. So now we are going to see buffering. Okay, so buffering is a flow control technique in which received data is stored in a temporary high speed memory location. It is called buffer. Okay, very simple. So buffering is a technique of flow control. So what is happening here? In which received data, for example, this much data came, so it is going to be stored temporary high speed memory location, and that is called buffer, until the main system components are ready to work with the data. Let me tell you a little more about it. I hope you understood this. Very simple. It will store the receiving data temporarily, and that is called buffer. Okay, and in networking situation, the network card itself handles buffering so that the system CPU does not have to become involved. So for example, this is LAN card. Okay, I'm just showing you here example. This is a LAN card. So this LAN card will handle this buffering. Even you must have seen buffering on your mobile if you are watching any video, or your data is not good, or you are not getting good speed. So that is what you see, it keeps buffering. You will not be able to watch any video properly. That is called buffering. So that is handled by your network only, mobile network. And buffering is also used when reading information from disk. So for example, if I'm opening anything that is coming from disk, so in that condition also buffering will play a role. Okay, and in which case the buffer is more often called cache. Okay, that is known as cache. And a cache controller, a specialized process chip, manages caching so that the CPU doesn't have to. So here one chip is there, okay, specialized chip that will handle that caching if I'm opening anything, and that chip will be taking care of that process. So CPU will not be involved here. So CPU will not have to do hard work here. Okay, in both the condition here, like in networking situation, LAN card will handle, or network card, that is also known as, okay, or this chip, a specialized process chip, okay, that is also known as a cache controller. So there are two things which will handle this buffering on a PC. If data is accessing from disk or any information is reading from disk, in that condition a specialized controller or a specialized process controller or chip, or if we are accessing anything from network, in that condition LAN card. I hope it is very clear. Okay, now I will show you something here. So here you can see, even with a high speed buffer, data can sometimes arrive too quickly to be handled. This situation is also called flooding. So now I will show you example. This is LAN card. Okay, here one PC is there. So this is known as network cache. It will handle, and if you are accessing any data, so you can see here high speed data buffering from network data. So for example, this is what if this machine is sending any data very quickly. So this is also known as flooding. Okay, and apart from this, to avoid flooding, okay, if you don't want this flooding to happen, a receiving device typical send a squelch signal to sender when the buffer is approximately 75% full. So here, to avoid this flooding, what will happen, this receiving device, for example this is a receiving device, it will send one squelch signal to sender. So what will happen, this upon receiving a squelch signal, the sender will slow or halt further data transmission until the receiver has caught up. So the situation is very simple. Now this will send one sequential number, this sequential number to this machine or this computer. It will tell you, please reduce your speed, I'm not able to handle the way this data is coming. Okay, so this is a scenario to manage this flow control, high speed data buffering network. I hope it is very simple, guys. I'm not making anything to be confused. Very simple, I'm telling you. Apart from this, now I will tell you some more things here. Okay, example of data windows. So what we have seen just now, what we have learned is buffering. I hope it is very clear. Now we will see about data windows. Okay, so guys, in the simplest case, a sender transmits one packet and then waits for acknowledgement from the recipient and acknowledgement signal. So same thing once again, here you have two computer, one is here, this is your sending, and one is here receiving. So if this PC is sending any packet, so it will wait until it sends a acknowledgement back to sending device, okay, or sending computer. If the recipient is busy, for example this computer is busy, the sender sits idle, so this machine, this computer will be sitting idle, it will not send further data, okay, until it receives the acknowledgement, after which it sends the next packet. So for example, it has two packets to be sent, 1 2 3. So if it has sent one packet and it is not getting any acknowledgement, so it will wait until this acknowledgement comes from here, and once this acknowledgement comes, it will send 2 3 to this machine, to this computer. Okay, very simple. And throughput could be increased if data could be sent in larger packages with the recipient sending fewer acknowledgements. So throughput is nothing but, guys, it is known as, let me tell you here in simple, throughput is a rate of production, or the rate in which at which something is processed. Or if you are talking about a network, so what does it mean actually here, such as Ethernet, if we are talking about a network or Ethernet, so throughput or network throughput is the rate of successful data exchange. Okay, how quickly, how faster this data exchange is happening, that is known as throughput. Very simple. So if I want to send this 1 2 3 data immediately, it should go immediately, that is known as throughput. And if more data is going in one package, so it gives you better output. Obviously you are able to send more data at one shot only. Now we will go further, we will see data window, little more thing about it. So guys, data windows provide just such a flow control technique, very simple, and multiple packets are sent as a unit called block or windows. The recipient acknowledges each window rather than each packet, resulting a high throughput. Apart from this, you can see here example without data window. Okay, data window is not involved in this. What is happening? Acknowledgement delay if receiver is busy. Okay, for you can see this is your sending and this is your receiving, and this data is going from here to here, and there is a if this computer is busy, so this acknowledgement is going to this machine, it may take some time without data window. Now what will happen if we are using data window here, data windows? So what will happen? Packets came, okay, packet is 1, or you can say 10 here it was 1, so it is coming from here, it came to this machine, it is sending you acknowledgement immediately. So this will be very faster, it will give you very faster throughput. Through Throughput, yes, correct. And the data exchange will happen smoothly, very faster. Apart from this, data window size can be fixed or variable. With fixed length window, every block contains the same number of packets. And to avoid flooding the buffers of some device, fixed length windows are typically small. So you can read guys here a couple of things. I'm not going with this one. This is a theoretical part here, but you can see here one example, fixed window here, always same size. Okay, for example, P1, P2, P3, P4, P5, this is fixed windows. Okay, and apart from this, there is one more windows known as sliding window. So guys, yes, sliding windows use variable block size. Okay, here they will not use same just like this 1 2 3 4 5. They may use variable block size. The first block sent contains a smaller number of packets, and each subsequent block is bit larger until the sender floods the buffer of the recipient. So let me show you example here. So this is what I was talking about, sliding window. So you can see here P1, P2, P3, P4, P5. This is first window. And apart from this, if you see P1, P2, P3, P4, P5, P6, P7, 8. Okay. And here you can see 11 came. Okay. 12, 13, 14, 15, 16, 17. Again 16 came. So this is known as adjusted window. Okay. And this is optimized buffer. And you can see fixed length and sliding window improves throughput. So guys, this is what I thought to bring in this video today. For example, for you guys, I hope it is informative. And for more videos, you can subscribe, like, share, and comment on this video. In next video, I will be talking about some other part of the same. And you can make a note of the story what I discussed with you. And the learning process, in every video I'm telling you, you should make a note. For example, what I discussed here is little bit lengthy, but you can make a note, like like throughput could be increased if data could be sent in larger packages. You can make a note of this. Okay, for example, this is I have given you this much lengthy definition here, so you can make like what is throughput. So throughput is nothing but it is the rate of successful message delivery. You can make a note this much only. So this is what we call true learning. So now it is up to you how you are making note, how you are learning. I can tell you just simple thing what you can do. For example, I couldn't discuss much more about this one. You can read, you can take a screenshot, and you can make a note, so it will help you to understand better from your side. So guys, I will meet you in next video. Till then, bye bye.